Welcome to RJ classes, and today we will do refraction of light through a thick glass slab. So we had done refraction, refractive index, and now refraction of light through a thick glass slab. Okay, so in order to do the refraction of light through a thick glass slab, first of all we need to understand that whenever light enters from a medium to the other medium, either it get speed up or speed of the light get reduced due to the molecular difference in the molecular pattern of the two medium, due to the presence of obstruction of different kinds. So now we are taking a glass slab. We have a glass slab. Suppose A, B and C, D is the glass slab, given glass slab, and we need to do the refraction of light. We will do the refraction, means we will refract the light from the air into the glass, from the glass to the air, and we will learn different changes that will take place whenever the light refract through a thick glass slab. Okay, so glass slab has been taken, thick glass slab. Now we need to refract a light through it, so we are taking an incident ray. Now we have an incident ray. Incident ray has been taken now from the air, and again it will enter into the air. The second medium again will be the air. First medium is air. From the air, first of all, what we are going to do, so light will incident from the air, it will enter into the glass. From the glass again light will enter into the air. That means air and glass, that means we have the rarer medium, and this one is again is the rarer medium, this one is the denser medium. That means here light is going to refract from the rarer medium to the denser medium, and in the next step light is going to refract from the denser medium to the rarer medium. That means we are going to do this one. Okay, so in this case we will see whenever light enter from the rarer medium to the denser medium, we have done it properly. Whenever light enter from the rarer medium to the denser medium, due to increase in the molecular pattern of the medium, speed of light reduces, and whenever speed of light reduces, light bend towards normal, and whenever the speed of light increases, light bends away from the normal. That we know very well. So this time light is traveling from air, and from the air light will enter into the glass. Remember properly. So from the air light is entering into the glass. That means light is entering from the rarer medium into the denser medium. So whenever light do such a thing, whenever light enter from the rarer medium into the denser medium, it bends towards normal. It bends towards normal. So light will bend like this one. And whenever light travel in a particular medium, keep in mind, whenever light travel in a particular medium, light always travel rectilinearly. That means in a particular medium light will always travel in a straight line. The only change will take place whenever the light will travel from a particular medium into the another medium, that is from the rarer medium to the denser medium. Only at that time light will bend, but in a particular medium light will always travel in a straight line. So this one is, so from the air light entered into the glass. This one is the glass block. So light entered into the glass, and so while entering into the glass it bends towards normal. Now this time, okay, from the air light entered into the glass. From this time, from the glass light is going to enter into the air. That means this time light is going to enter from the denser medium into the rarer medium. So this time whenever light enter from the denser medium to the rarer medium, it bends away from the normal. So this time speed of light will increase, that means it will get away from the normal. So if we draw a normal here, okay, so whenever light enter from the glass to the air, so it will bend away from the normal. This one is the angle of incidence, this one is the angle of refraction in the first person, and this one is the angle of emergence, angle of incidence, angle of refraction, and this one is the angle of emergence. Now the whole diagram we have done, but yet it is not complete. We need to do something more. There is another word. So light entered from the air into the glass, it bent towards normal. When it bent from the glass into the air, it bends away from the normal. So under such a situation, you will observe that the angle of incidence, the measure of angle of incidence and the angle of emergence will be completely equal to each other. Measure of angle of incidence and the angle of emergence will be equals to each other. Achha, angle of incidence, angle between the normal and the emergent ray, emergence. So angle of emergence, angle of incidence, that we have studied, that we know. Angle of refraction, that we know the definition of that one. Now we have the angle of emergence. Angle of emergence, and before that this one is called emergent ray. Emergent ray. So what is the definition of emergent ray? Whenever a ray of light from a medium travel into the another medium and back to the same medium and again back to the same medium, ray thus obtained is said to be the emergent ray. Again I am repeating, whenever a ray of light travel from a medium to the another medium and again back to the same medium, ray thus obtained is said to be the emergent ray. Okay, and angle between the emergent ray and the normal is said to be the angle of emergence. Now we got, and value of angle of incidence and angle of emergence will be completely equal to each other. So this one diagram is near about got completed. Now if we produce the incident ray, we will see that the incident ray and the emergent ray get parallel to each other, both get parallel to each other. So they will never intersect each other, they will become parallel to each other. And if we draw a perpendicular distance between them to measure how they are parallel, what is the distance between them? So perpendicular distance, we have the word lateral displacement. So the perpendicular distance between the emergent ray and the produced incident ray is said to be the lateral displacement. So what is the lateral displacement? I think you have got it. What I am saying, whenever the incident rays are produced, this is we will not get exactly this kind of any ray. We have produced it, we have imagined it that if the ray of light has not been bent, it has passed straight in this manner. So under that situation, what would have happened? So that's, we have drawn a imaginary line. Imaginary ray is passing through this one. So dot dot, that means that this is not the real line, but this is the imaginary line. So if the incident ray is produced a straight way, that means supposing that it will not bend at any of the surface. So under that situation, the emergent ray and the produced incident ray, they will become parallel to each other, and and if a perpendicular line is drawn between them, so that will be perpendicular distance is drawn between them, so that is said to be the lateral displacement. So we have the definition of lateral displacement is perpendicular distance between the incident ray and the produced incident ray and the emergent ray is said to be the lateral displacement. Now, so diagram near about got completed. Now another term we have, that is the lateral displacement. Now we are going to discuss lateral displacement. So whenever you need to draw a diagram for refraction of light through a thick glass slab, you will do the refraction in this manner, and only diagram part is essential, descriptive part is not essential. That never come in, that will never come in your question paper. So yes, Sometimes to draw the means refraction of light through a thick glass slab, that come in your exam. Now lateral displacement. So lateral displacement depend upon certain factors. This one completed. So diagram is this was the diagram, and we will do the diagram in this manner. We will draw each and everything, incident, refraction and the emergence, lateral displacement. You will do each and everything, then only will diagram considered to be completed. Now lateral displacement depend upon the certain factors. The first factor on which the lateral displacement depend, first one is the thickness of the glass slab. Thickness of glass slab, thickness of slab, yes. So more thick will be the glass slab. So you can write it here like this one, lateral displacement is directly proportional to the thickness of the glass slab. Thickness of the glass slab. That means more thick will be the glass slab, more will be the lateral displacement. Next one. So whatever. So more thickness, more will be the lateral displacement. So for thick glass, there will be a more distance between the produced incident ray and the emergent ray. The next one is the dependence on the angle of incidence. Second one is angle of incidence. Angle of incidence. Again, angle of incidence. Angle of incidence is directly proportional. And you can write it here, lateral displacement is directly proportional to the angle of incidence. That means if you throw a light, if you incident a light at a greater angle, there will be more the lateral displacement between the emergent ray and the produced incident ray. So lateral displacement will be more for the having a greater value of angle of incidence. And the third one, that is the dependence on the refractive index. Third one is refractive index. Refractive index. Refractive index of light is such a property that influence most of the things. So most of the property of light is decided, most of the property of light is compared with refractive index. So lateral displacement, this time also lateral displacement is directly proportional to the refractive index of the light. That means more will be the refractive index, more will be the lateral displacement of the light. And refractive index, sometimes you will have the question in term of the wavelength, because refractive index and wavelength both are complementary to each other. Sometimes you will have the question in terms of the color of the light. So under that situation, compare how refractive index is related to the wavelength, how refractive index is related to the color of the light. There is a video, you can go to that section and see how is the refractive index related to the wavelength, how is the refractive index related to the color of the light. So lateral displacement will directly proportional to the refractive index, and with the help of refractive index we can also relate the lateral displacement to the wavelength. We can also relate the lateral displacement to the color of the light, and sometimes we can say the nature of the material. That is sometimes, that is not the official factor, but sometimes it also influence the lateral displacement. Lateral displacement sometimes also get influenced due to the nature of the material. So this one is the refraction of light through a thick glass slab. So this section, lateral displacement, refraction of light through a thick glass slab, that has been completed. In next video we will do next topic.